Welcome. This is part two of special angles. We are continuing. So you will remember that we did talk about these nice angles that we can somehow develop. Uh, that we can somehow develop from this analogy here of these two very special triangles, and then we define them and say that they are, in a sense, integer multiples of 45 and 30-degree angles. So now that we've defined that, and I hope that you've refreshed this and you know what is happening. If you're starting watching this video, it's a continuation of my video on special angles and their evaluation, and you can go back and watch it before coming to watch this one. Um, we are going to continue with what we had already started. So let's maybe try and come this side here and draw a line, and then we're going to continue computing from this side. But we'll be working with this ideology here. This here is very important. It will tell you everything you need to know about what a special angle is. So we're working with that analogy there. Now we have these two triangles that we developed. These two special triangles containing our three special angles. Now, the special angles that we're going to be focusing on are three. This is going to become apparent as we start more and more properties of trigonometric ratios and special angles. It's going to become apparent why we're going to be focusing only on these three. We've already focused on 90 and 0. Now we're going to be focusing on 60, 45, and 30. Now you will understand that if you look before, if you now, one thing that you should understand that should also give you a hint is that if we look at a Cartesian plane, or and you look at x and y, and we say that this here is two lines, these lines are meeting at 90 degrees. So if you draw a line here, you will get a line that is 30 degrees. You draw another one, that one will be 45 degrees. You drawing it from here, and then if you draw another one, you will get that one being 60 degrees. So we can tell that now from 0 degrees to 90 degrees. There are how many special angles? There's 0, 1, then 92, and then there's 30, there's 45, there's 60. We saw this by this. All other angles are not special angles. So then, in a sense, now we will feel it. Okay, that means there are how many? There are 5 angles. There are 5 special angles between 0 and 90 degrees on the Cartesian plane. We'll explain further what the Cartesian plane is when we develop other topics in mathematics. For now, I want us, in fact, we're not developing algebra. For now, I want us to look at these special angles and draft the table. So we are going to draft a nice table here. So this table is going to consist of before maybe we draft this table, let's go and fetch our triangles again. They are our triangles. So what we're going to do is that we're going to fetch them and take them down there. So we're going to take both those triangles. There's triangle number 1 that we looked at. This is the one with 60 and 30, and then this is 1, 2, and then this is 3. And then we'll also look at another one. This is the one with 45 and 45, and this is called 1, 1, and 2. Right. So, and then this is the opposite side, which is the adjacent side. This is the hypotenuse side. Now, what I'm doing here without quantifying it is wrong, because this is adjacent to this 45 and that is opposite to that 45. So I'll always be referencing with this angle here whenever I define my triangles. So also here, this is the opposite, this is the hypotenuse, and then this is the adjacent side. So in a sense, we can go then and say, well, we want to develop our ratios, and you know our ratios, sine, tan, and cos. The three ratios that we have is sine, tan, and cos. So we are going to develop them. Let's try and make the screen smaller so that we can do everything on one screen. So if we can make it even smaller, even smaller, even smaller, and then try and develop everything on one screen. So let's take a nice thicker shape. Let's take big 3. So we will write a nice table here. We'll have a nice table here. How does it enough? And then this table here will have angle. And then under angle, we will have the 3 angles, angle theta. And then under angle theta, we'll have the 3 angles. So the first angle is 30, the second angle is 45, and the last angle is 16. And then on this side here we'll have ratio, and then from ratio we'll have sine, we'll have cosine, and we'll have tangent. This is a tangent of theta, cosine of theta, sine of theta. And then we can draw this here, and then we can do that there, we can do that there. We can combine this, and then what we will see here is a very nice picture. So now we can define these ratios specifically from those triangles. So sine theta, this theta that we're talking about in this case is 30 degrees. It's 30 degrees. That's the theta now that we're talking about in this case. That's the value of theta in the case of 30. So it's what it's going to be, because it's sine, it's opposite of hypotenuse. Remember, when we are at 30, this is the opposite side to 30, and it's adjacent side, and it's hypotenuse. So it's going to be 1/2. That was it's going to be sine of 30. So it's going to be it's going to be 1/2. So it's going to be this side divided by that side. So in fact, you can do these evaluations yourself. You can pause this video before we continue and do these evaluations yourself, just to see and to be able to see if you've understood what we've done here. From what we've done, you should be able to do these videos by yourself. But then if you look at sine 30, it's going to be 1/2, because we're looking at that side there. So that's 1 divided by 2. And then we also look at cos 30. We're looking at that side again. So cos now is this side, is adjacent side over that side. So it's going to be √3/2. In fact, you can also confirm this on your calculator. Just press on your calculator, just to be sure. Once you've done and verified, the calculator should give you the same answer as here. And then you look at tangent. Tangent is going to be what? Now it's going to be opposite over that, so that's going to be 1/√3. You can also verify that also on your calculator. So you have to have a Casio calculator or any other trig calculator, or any other calculator that can evaluate trigonometric ratios. So it's going to be 1/√3. In most cases, I think on your calculator it's probably going to be √3/3. What they do is that they multiply this ratio here by √3/3, which is actually 1, to try and get it to look appealing, but we're not going to do that, so it's fine. But then what they actually do is that when you get a value like this, √3/3, and you multiply it by √3/3, this is actually 1. So you haven't done anything, you haven't changed the value, because this is √3 divided by √3, which is 1. So whenever you multiply a value by 1, you get that same number as the answer. That's why we call 1 an identity multiple. It's because it gives you exactly the identical value after multiplying by it. So we get here, we're going to get √3 on the top, 1 times √3, and then at the bottom, when you times the root by root, that becomes the number. The root cancels itself. So that's what the calculator is probably going to show you, depending on what type of calculator you're using. Some will show you that, some will show you this, it depends. Then we look at 45. Then we can look at 45. When we're looking at 45, we come to this triangle here, and then we say we want to look at sine of 45. So sine of 45, it doesn't matter. You can use this 45 or you can use that one. It's going to be the same. So in a sense, sine of 45 is going to be 1 over root 2. 1 over root 2. Also, the calculator must be using the same principle. If it's using the same principle, it's going to be actually root 2 over 2. And then here on cos of 45, still going to be getting 1 over root 2. So we're finding something very nice here. We can already see something here that cos of 45 is actually equal to sine of 45. This will come in very handy also, knowing these and being able to relate them when we are simplifying trigonometric expressions. These are going to come in very handy, this analysis and being able to analyze this. So I hope you've seen something very special here. So now we can go again and say, well, we're looking at tangent of 45. So tangent of 45 is 1 over 1, which is 1. And then we go and look at 60 coming back to this triangle, and we evaluate 60. We say now the adjacent side is 1. So if we're looking at opposite, that's that. So that's root 3 over 2. I hope you're also seeing something here. That cos of 30 is actually equal to exact side of 30. So that's something very also nice to understand and see. And then when we so that's another identity or axiom that we can derive already, that cos of 30 is actually equal to sine of 60. We can see that here's cos of 30, there is sine of 60. Then we can go again and evaluate cos. We're now evaluating cos 60. Now if you look at this, you can already tell that there's going to be some relation also between cos and sine, in this case that we're having 60. So if we look at cos of 60, where is cos of 60? This is it here. It's adjacent over what? Over hypotenuse. So it becomes 1 over 2. Now you can see again that sine of 30 is equal to cos of 60. Very nice. Just swap the angles around and they still become equal. This is also a very useful tool or useful understanding to never forget, but we will continue developing these ideas and finding ways to evaluate them in an even more nicer way. So we're going to look at tangent again. We're going to look at tangent of 60. So when we look at tangent of 60, we're looking at opposite of adjacent. So it's root 3 over 1, which is going to be just root 3. So you see now that we special triangles, because they have these very special traits, it's very easy to compute their their ratios. So they are very special. You can also add here 0 and 90 and then go and take their values from this side here and just populate that to make sure to include all the 5 special angles between 0 and 90. So you can come and take this here and go at this 0 column and at this 90 column. And then, but don't forget where these analyses are coming from. And if you haven't watched the video where we look at the special angles of 0 and 90 and how to evaluate them, I think it's best that to watch it because they are very different evaluations compared to special angles. And they are much more intricate, which is why I started with them. These ones are much more simpler and easy to remember. This table here. So this here and the table there, they must be your friend. This is called a table of special angles. If you add 90 there and 0, you get all the special angles between 90 and 0, including both 90 and 0. And that's another very useful information to know. So always know that when you talk about special angles, or when you see a triangle that has got 60 as an angle, a right angle triangle that has got 60 as an angle or 30, that one falls under a special angles triangle, and is always going to follow this table. Also for 45 is always going to follow this table. 90 and 0, I didn't include them on this table because the evaluations are quite different and you need some intuitive reasoning behind it. But I hope that from the video that we did get a very clear understanding as to how we get to the values of cosine of 0, or to all the trig ratios of 0 and 90. I hope you now have an understanding of what we've been doing. In summary, we have looked at the introduction to trigonometry. We have looked at different ways of computing angles and different ways of computing triangles, of computing ratios, either from the angle side or from the value side. So we can look at it from the ratio side or from the actual value side on a triangle. So when you're looking at it from the actual value side on a triangle, that's what we're doing here. When we're looking at 90 and 0, we actually try to look at things more from the angle side of things. But also still here, there's still a relationship. So here, as you can see, that we are making measurements, we are doing relationships between the angles and sides on three-dimensional, not on three-dimensional shapes, but on three-sided shapes. Dimension is different from sides, yeah. So it's three-sided shapes with the triangles, and those triangles, they must be plane triangles, which means they must be triangles that meet at 90 degrees. Now, this is going to be it on the fundamentals of trigonometry. From here, I don't know, maybe I can post some questions. I'll do a question session where we will look at different questions. Where we can do this, we look at different nice evaluations, some different triangles where you can get a grasp of everything before we move into what we call the sine and cosine and tangent, the sine and cosine sinusoids, and then also look at the tangent graph. So I hope you enjoyed that, and if you have any questions, please ask. Try and familiarize yourself with this and get the basic idea before you go to the question session. And post the questions, and then you can pause the video on the questions and then do the questions yourself, and then see also how I continue tackling them, and you can compare your results with that to see if you did understand anything that we did here. So that's going to be it for this video, and see you on the question session.